Okay, so this is the second half of the summer 2018 Numeracy paper 2. We've got through all the D and E questions and we're now entering the C and B questions. So question 7. In October 2011, a charge of 5 pence for a carrier bag was introduced in Wales. Money raised from this charge is given to charity. For the period 1st of October 2011 to 31st of January 2015, it was estimated that a total of between 16.8 million and 21.9 million was donated to charity. This is a result of people buying the 5p carrier bags. Calculate an estimate. Okay, so they're not expecting us to get exact answers here of how much per month was given to charity between 1st of October 2011 and 31st of January 2015. So it's how much per month. So the first thing I need to do is work out how many months there are. So I've got October 2011 to October 2012, October 2013, October 2014 is 3 years. And then it's from the 1st of October, so in months I've got to include October 2014, include November 2014, include December 2014, and include January 2015. So that period of time is actually 3 years and 4 months. 3 years is 36 months, 3 12s, plus 4. So 40 months. And the amount of money that was donated in that period of time is between 16.8 and 21.9 million. So because we're estimating, we want to go somewhere in between. 18 million? That's all right. So I'm estimating 18 million. You could have found exactly halfway, as you would with the mean of group data, by adding those two together and dividing by 2. It doesn't matter, so long as your estimate is reasonable between those two values. So in order then to work out how much per month, I'm going to do 18 million divided by 40. Which you can keep in words or you can type it in. 18, 1, 2, 3, 4, 5, 6 divided by 40, 450,000. Oops, that's 45,000. So 450,000 pounds. If you had 19 there, it wouldn't matter. The mark scheme allows you an answer of between 400,000 and 550,000. You could have used that minimum value. You could have used the maximum value or anything in between. So the marks for that, there's one mark for the number of months, and you wouldn't believe me when I said how few I marked last summer where I was given that mark. So many people couldn't work out the number of months. Then you've got a method. Oops. A method for what are you estimating? What value are you going to divide by 40? A method mark for showing you're dividing by 40. And then your answer mark, as I said, for any answer that comes between £400,000 and £550,000. B. Over time, there has been a reduction in the use of 5 pence carrier bags. This is because more people are using their own bags. What impact might this have had on the amount given to charity for the month of September 2014 when compared with September 2012. So all you need to say here is the amount of money raised will go down. It'll reduce because in 2014 there were fewer people buying the bags than in 2012. So the amount given to charity will be reduced. 1 mark. Question 8. This was badly answered. Megan and Rodri both set out at the same time from home to go to the swimming pool. Rodri travels by car. Megan cycles straight through the park. Rodri's journey by car is 5.5 miles. His average speed for the journey is 22 miles an hour. So immediately now I'm thinking, ooh, I can use my speed, distance, time triangle here. So let me transfer that over. Speed, distance over time. Megan's average speed on her bike is 12 miles per hour. Megan arrives at the swimming pool 5 minutes before Rodri. Calculate the distance Megan cycles. Give your answer in miles. You must show all your working. So let's look at Rodri first of all. I know the distance. I know the speed. So if I know the distance and the speed, I can work out how long it took Rodri to get there. So time is distance over speed, which is 5.5 divided by 22. Now, we're working with time and we have the calculators at our disposal. So we're going to use the magic time button. 5.5 over 22 equals a quarter. Now, a quarter of what? Distance is in miles, speed is in miles per hour, so the time is going to be quarter of an hour, which is no hours and 15 minutes. So all I did then was press the time button and it turned the quarter into 0 hours 15 minutes. That's really, really important because the most common mistake is to say that's 0.25. Okay, so I know that journey took Rodri 15 minutes. So now I can think about Megan. Megan's average speed on her bike was 12 miles per hour, so I got the speed. And she arrives at the swimming pool 5 minutes before Rodri. So if they left at the same time, and she got there 5 minutes earlier, and it took Rodri 15 minutes, then Meg's journey time will be 15 minutes less 5 minutes is 10 minutes. So for Meg, I know how long it took her, the time. I know the speed she was doing, so I can work out the distance. Distance is speed times time. Her speed was 12, and the time, I know this is super important, we're using the time button. It's no hours and 10 minutes. So on the calculator, we do 12 times 0 hours, 10 minutes. So you have to put in, tell the calculator, I got no hours. So it's 0 time button, 10 time button. That gives you that. Now, because the distance is in miles, I don't want it in hours, minutes, and seconds, so I press the time button one more time, and it turns it to 2 miles. So that time button is really, really well worth learning to use. It saves you messing up 15 minutes and a quarter and 10 minutes and so on. The marks for that, there's a method mark and an answer mark for 15 minutes. There's a method mark for working out megs taking 10 minutes, and then there's a method mark for working out the distance, and an answer mark for the final answer. Part B. Gary travelled a distance of 231 kilometres in 3 hours and 10 minutes. Calculate Gary's average speed. So we're still on speed, distance, time. So speed is distance over time. So that's going to be 231 over 3 hours 30 minutes. The mistake or the trap they want you to fall into here is by doing 231 divided by 3.30. It's not. It's 231 on top, and underneath 3 hours 30 minutes. So we'll go back to that time button. 66 kilometers per hour. It's the one that's got the, it looks like it's got commas and full stops on it. See where my pen is pointing? Ah, okay. So that's a really, really good button to get to know how to use. One mark for that, so it's just whether you manage to circle the right answer. Question 9. Yared is going to make a door wedge. The cross section of the wedge is shown below. The horizontal length is 12 centimeters and the vertical height is 3 centimeters. Calculate the length x. Right, we're in the second half of an intermediate tier, so I'm expecting Pythagoras and I'm expecting trig. I've got a right angle triangle there, and it asks me to find a side when I know 2 other sides. So it's Pythag. Pythag, we square the sides. So I've got my 12 squared, which I don't need a calculator for, and my 3 squared, which I don't need a calculator for. So that's job 1. Job 2 is decide whether to add these or subtract them. If you're trying to find the largest side, which is pointed at by the box, so that's the hypotenuse, the longest side, I need the biggest answer out of those, so I'm going to be adding them. If it was one of the shorter sides, I'd be subtracting. So I need to add those together, and I get 153. But I don't want the squares, I want the lengths. So I've got to do the opposite now of squaring, which is square rooting, and I get 153. So square root of 153, and I get a big ugly string of decimals. Now, because this question wants you to do a rounding, I suggest you first of all write down the answer on your calculator screen beyond the rounding, in case you muck the rounding up. This one is for significant figures. With significant figures, you start counting immediately, because the most significant in this one is that, because it's in the tens column. So I want 3 significant figures, first, second, third. So my answer is either going to be 12.3 or 12.4. Look at the next digit along, it pushes it closer to 12.4. So with that question, there's 1 mark for the correct squaring and adding. There's 1 mark for showing the square root of 153. And then there's 2 marks for the correct rounding. So there's 2 marks for the Pythag, and there's 2 marks for the rounding. Part 2. The wedge must fit under Yared's door. The angle Y must be less than 15 degrees. Show that the wedge will fit under Yared's door. Alright, so I'm still got a right angle triangle, and this time I want to find an angle, so I know it's trig. First thing I need to do is name my sides. Well, I've already determined that that's the hypotenuse, because this is what's being pointed at. The angle that I'm working with is here, so this is the opposite, and what's left is the adjacent. So to find the angle, I need the combination that has both the O and the A in. So I go back to my trig triangles that I wrote down at the start, and I'm looking for the one that links O and A, which is toe. So I'm going to write that down now, straight away. So I'm looking for the angle, which means I cover up the letter. So tan of Y, of the angle, is opposite over adjacent. So tan of Y is the opposite, which is 3, over the adjacent, which is 12. Now to get the angle, the buttons on your calculator, you've got 2 for sine, sine and above it, sine to the -1, 2 for cos, 2 for tan. If you're working with an angle, you're just going to press tan. If you are trying to find an angle, we have to do the opposite of it. So we write that as tan -1 of 3 over 12. And we type that into the calculator so that it looks exactly like that. So shift, tan, fraction button, 3 on top, 12 on the bottom, close bracket, equals 14.0, or just 14 degrees, doesn't matter. Will it fit underneath? Yes, it will. Because it's less than 15 degrees. Mark for that. So there's 2 marks for the correct trig and fraction and inverse, and 1 mark for the answer and saying yes, it will fit. Part B. Yared decides to make a larger wedge that is mathematically similar. That is a trigger for a specific topic in maths that your brain should be then figuring. To the one shown in part A. The wedge is to have a vertical height of 4.5. Calculate the horizontal length of this door wedge. So I want to find that. It's not drawn to scale, so I can't measure it, but they're telling me that it's similar to this one. So if I draw this one again, on that one I know the 12, I know the 3, and with similar shapes you're looking to find what the multiplying factor is between the corresponding sides. So what have I got to multiply that by to give me that? So to find that out, you do 4.5 divided by 3. And I've slipped into red pen, which is 1.5 or 1.5. So I've got to times this by 1.5, and if it's similar, once you've worked out that scale factor, every other side corresponds by the same factor. So if that's 12, this is going to be 1.5 times bigger. So it's going to be 18 centimeters long. If they gave you a value in the big shape and you wanted to find the value in the small shape, you would divide by the scale factor. So the first thing you do is work out what the scale factor is by matching the two corresponding sides. Then, because I'm enlarging, I'm timesing by that scale factor, but going the other way, you'd end up dividing by it. So there's 2 marks for that, 1 mark for finding the scale factor. And correctly getting the 18 centimeters. So look for that word similar. It immediately tells you you're looking for a scale factor in order to work with to find the other sides. Question 10 was by far and away the most poorly answered question on this paper. A grass racetrack is shown in the diagram below. This is the region shaded in the diagram, so the grass is the grey bit. Each end of the grass racetrack is created from semicircles. The inner semicircles have a radius of 15. The outer semicircles have a radius of 20. Each of the straight sections of the racetrack has a length of 65 meters. What is the total area of grass in the 2 straight sections of the racetrack? You must show all your working. Okay, so if we think about this, what we have here in the straight section is a rectangle. Okay, we've got a big rectangle which is 65 times 20. Sorry, 65 times 40, because it's 20 that way and 20 that way. And this one, which is that's 65 times 20 as well, or the inside one, which is times 30. Okay, or the gap here is how much of a gap? 5. Yeah, it's 15 from there to there. It's 20 from there to the outside. So I've got a gap which is 5. So this rectangle is 5 times 65. So its area is 65 times 5. Which is 325, which means up there, that one is also 325. So the total area of grass in the 2 straight sections is 2 lots of 325, which is 650 square meters. So marks for that before I turn the page is a method mark for 65 times 5 times 2 and an answer mark for 650. Then we come to part B. Calculate the area of the grass racetrack. You must show all your workings. Well, I've worked out now what the area of that grey bit is and that grey bit. So what I'm left with is the area of the 2 curved bits. Now if I put 2 semicircles together, I get a full circle. So what this actually makes is two full circles, one with a radius of 15 and the outer one which has got a radius of 20. So if I work out the area of the big circle and work out the area of the little circle and take them away, it'll leave me the gap in between. Okay? So the area of the outer part one of the formulas we wrote down straight away, area equals area is pi r squared. So pi times, and the outer circle has got a radius of 20. So on my calculator, the pi is above the times 10 button there. So to get to pi, you do shift and times 10. So I'm going to do pi shift times 10 times 20 squared, exactly as I've written it. Gives you that horrible answer. So one of the problems with this is you never know if it looks right. Okay, you can't be confident. Now, they've given their measurements to the nearest meter, so I can give my measurements to the nearest meter. So that will be 1257 meters squared. Then I work out the area of the inner circle. Which will be pi times 15 squared. Why have I written 12? So pi times 15 squared. And that's going to be 707 square meters. So the area of grass will be 1257, take away the inside circle. (550 square meters). But I've got, that's the area of the grass on the circular parts, the curved parts. I've also got another 650 square meters of straights. So that will be the 550 plus our answer to part A, which is the straight sections. So the actual answer is 1200 square meters. Now, circles don't go down well in the intermediate tier, in my experience. So that, as I said, was really not well answered. Marks for that. So there's method for working with an area of a circle. There's a method for remembering to add your 650, and an answer mark for 1200, or there or thereabouts if you decided to go to 1 decimal place or 2 decimal places. Part C was quite good because even if you got part B completely wrong, so long as you had a value for it, you could still answer part C. The grass is to be treated with a fertilizer. It costs 20 pence to treat each 3 meters squared of grass. How much will it cost to treat the grass racetrack? So I've got 1200 square meters, so I want to see how many blocks of 3 go into that. So I've got to do 1200 divided by 3, so 400, times 20 pence, but they want it to the nearest pound, so if I put it in like that, £80. So there's 1 mark for the method there and 1 mark for the answer. But as I said, any area that you'd taken from part B, no matter how wrong it was, you could get full marks for part C if you'd done that part right. Question 11 is the scariest looking thing you'll ever see, but actually is quite a nice question. Hot water is often stored in cylinders. The water in the cylinder is heated for use in the shower. A plumbing engineer wants to calculate how long a shower can be used continuously before the water runs cold. He uses the following formulae. So we've got those 2 formulae there, and then letters and what each letter stands for. I won't read through. Daisy's cylinder holds 300 litres of water. The temperature of the hot water is 60 degrees. The temperature of the cold water that feeds into the cylinder is 8. The water in Daisy's shower is set at a temperature of 32 degrees. Her shower has a rate of flow of 26 litres per minute. So all we have to do here is match each of those with the correct letter, the correct variable. So let's do it one at a time. Daisy's cylinder holds 300 litres of hot water. So the one that relates to is H, is the volume of hot water that the cylinder holds in litres. So H is 300. And then I'm going to put a little tick next to that to know that I've dealt with it. The temperature of the hot water in a cylinder is 60 degrees. M is the temperature of hot water in the shower. So M is 60 degrees. Done that one. The temperature of the cold water that feeds into the cylinder is 8. Temperature of cold water that feeds into the cylinder is Y. So Y is 8. Yeah. Hang on. Sorry, X is 60, quite right, thank you Maisie. The temperature of hot water in the cylinder is 60, so X is 60. Temperature of the cold water is Y, yeah, happy with that? The water in Daisy's shower is set at a temperature of 32. Where is that? So that's M. Yeah, M is 32. M is the temperature of water in the shower. So M is 32. The shower has a rate of flow of 26 litres per minute. That's F. So F is 26. Okay, so I've ticked all of those. Then I've got C equals H bracket X take M, M take Y. I've got a value for H, I've got one for X, I've got one for M, I've got one for Y. So my super duper calculator, let's put those in, 300 bracket 60 take 32 over 32 take 8. I can put that into my calculator exactly as we've written it. So I need a fraction. On top, 300 open bracket 60 take 32. And on the bottom, 32 take 8. 350. And then my second formula is T equals C plus H over F. So C is 350, we just worked that out. H is 300 and F is 26. And once more, we can just type that in So long as you're confident in how to use your calculator, you haven't got to worry about, oh, I need to take those away, or do I work out what brackets first? Your calculator will do it all for you. So there were 5 marks for that. 2 marks for correctly substituting in all that. So if I see those numbers all in the right place, and 1 mark for the 350, and then 1 mark for correctly substituting into the second one, and 1 mark for the 25. It's not even asking you to put the units on it. And then the final question. Dr. Khan and her daughter Farrell have different opinions about the mean temperature in their hallway. Dr. Khan and Farrell recorded the temperature in the hallway at 4 p.m. each day during the 30 days of April. In her notepad, Dr. Khan summarized the temperatures in a group frequency table. Unfortunately, Dr. Khan has torn the page containing the table from her notepad and has lost some of the original data. Calculate an estimate of the mean. So this is something that you will have been revising and waiting for. It comes up pretty much every year, and I hope it does again on Thursday. When you're estimating the mean, you need the midpoint. So halfway between 20 and 21 is 21.5. The next one, this one's a nice easy one. You can see 23, no, what have I done there? 20, sorry. He says it's easy and then he gets it all wrong. It's 20.5, 21.5, 22.5 and 23.5. But hang on, I'm missing a number of days. So I know it's in April because it tells me up there, and it's even telling me how many days there are in April in case I don't know. So that should add up to 30. At the moment it adds up to 20. So the missing number of days there is 10. In order to estimate the mean, I need a total. I know there are 4 days between 20 and 21. I'm estimating they're all going to be at 20.5. So to work out the total, I times your midpoint by the number of days. So I do 20.5 times 4, and I get 82. I then do 21.5 times 8. I do 22.5 times 8. And I do 23.5 times 10. To find the mean, it's the total divided by the count. The count is 30 because there are 30 days. The total I get by adding those together. So 82 plus 172, 180, 235. So that comes to 669. So 22.3 degrees is my estimate. Marks for that. There's 1 mark for the 10. So just for working out missing days. There's 1 mark for correctly listing the midpoints. There's a method mark for doing the multiplying and adding to get 669. There's a method mark for dividing by 30 and an answer mark for 22.3. So in a question like this, it's really important you write down as much of the calculations as you can. And then the very final part, what assumption have you made in calculating an estimate of the mean temperature at 4 p.m. for April in Dr. Khan's hallway? So what they're looking for you to say there is that you are using the midpoints. You're assuming they're all around the midpoint. So all around the mid-values. Farrell recorded the same temperatures as her mother at 4 p.m. each day during April. So she's got the raw data. She found the actual mean temperature during April was lower than the correctly calculated estimate of the mean. So when she added up all the original values, her mean temperature was lower than 22.3. Explain how this can be true. Well, we are assuming that everything is rounding to the middle. In fact, the temperatures may have been, or most of the temperatures might have been lower than the mid-values, which would make that lower. If they'd have been higher than the mid-values, then it would have been a higher temperature. So all you want to say there is possibly most temperatures were lower than the mid-values. And that would then make that the case. So lots of people got that mark. Very few people got that final mark there. Okay, so those are quicker, definitely quicker doing the paper 2s than the paper 1.